Hello everyone, I am Dr. Venkateswararao, Assistant Professor, PG Department of Chemistry, Sri Vayan College, Narsapur. In the last video, we had gone through the concept of equivalent weight, and we came to know that the calculation of equivalent weight of an element, acids, bases, salts, oxidizing agents and reducing agents. Moreover, equivalent weight of a substance depends upon the nature of chemical reaction in which the substance takes part. Now, I shall make an attempt to explain the mole concept in solutions. Already I told you, chemical substances are being quantified in moles. For example, if you take any chemical substance, for example, sodium chloride, it is being quantified in moles or in grams. That is, 1 mole sodium chloride is equal to 58.5 grams. 1 mole is equal to 58.5 grams, and of course this is equal to gram molecule. Therefore, if you take any chemical substance that can be quantified in moles or in grams, usually we quantify the chemical substances in moles. As long as the chemical substance, here the sodium chloride, as long as it is in the solid crystalline form, we can quantify that sodium chloride in grams or in moles. But what happens when sodium chloride dissolved in 1 liter water? What happens? Sodium chloride dissolves in that 1 liter water and solution tastes salty, and of course we can increase the saltiness of that solution by increasing the amount of sodium chloride in that solution. Similarly, we can decrease the saltiness of that solution by increasing the volume of water. In chemistry, that saltiness is termed as concentration. Then, can we quantify the sodium chloride in that 1 liter solution? Then the answer is yes. We can quantify the sodium chloride dissolved in that 1 liter water. That is, salt, we add solvent, that is solvent being dissolved in solvent, it gives a salt solution. In chemistry, this salt is called as or termed as salt plus water. Salt plus water gives salt water. salt plus water gives salt water. In chemistry, salt is termed as solute and water is termed as solvent, and this salt water is termed as solution. Therefore, solution contains two components. One is solute and another one is solvent. Usually in solutions, solute is in less in magnitude or less in quantity. So, solution contains two components. One is solute and another one is solvent. Now we can quantify the solute present in this solution. How can we quantify the sodium chloride in that 1 liter solution? Let us go for one example. Let us go for one example. If 5.85 grams of sodium chloride dissolved in, if 5.85 grams of sodium chloride dissolved in 1 liter water, that forms salt water. In chemical terminology, that salt water is called as a solution, because in that solution there is a solute. Here sodium chloride is a solute and water is solvent. So when we dissolve 5.85 grams of sodium chloride in 1 liter water, can we quantify that sodium chloride? We can quantify that sodium chloride. How can we quantify that sodium chloride? We can quantify that sodium chloride, and we can quantify that sodium chloride. How? We know, when we know the weight of chemical substance, we can convert that weight into moles. We know the weight of solute or weight of sodium chloride. We know weight of sodium chloride, that is 5.85. If we divide this 5.85 grams of sodium chloride by its molecular weight, then it gives number of moles. Molecular weight of sodium chloride is 58.5, so that gives 0.1 mole. That means 0.1 mole of sodium chloride dissolved in 1 liter water. So we can quantify that sodium chloride that dissolved in 1 liter water as mole per liter. Mole per liter. Here number of moles is 0.1, and 0.1 mole of sodium chloride dissolved in 1 liter. So moles per liter. Moles per liter. Moles per liter in chemists, they assigned one terminology for this ratio, moles per liter. It is called molarity. It is called molarity, and they assigned one term for this ratio, moles per liter. moles per liter. Whose moles? Solute moles. Whose moles? Solute moles. So now we can define this molarity as number of moles of solute present in 1 liter solution. So molarity definition is number of moles of solute present in 1 liter solution. Okay, so number of moles of solute present in 1 liter of solution is called molarity. What is this molarity says? This molarity says the quantity of sodium chloride or the quantity of solute that is being dissolved in 1 liter solution, and molarity is equal to moles per liter. We know mole. How can we write mole? Weight by gram molecular weight. Here weight by, this is weight and this is molecular weight. Weight by gram molecular weight. Gram molecular weight. Weight by this moles is mole. We can calculate the number of moles by using the ratio weight by gram molecular weight by liter. Usually this liter is represented with V, that is 1 liter or 2 liters or 3 liters. But usually the definition, as per definition, number of moles of solute present in 1 liter of solution is called molarity. So we can write instead of liter V. This fraction becomes as weight by gram molecular weight into 1 by V in liters. So molarity formula is weight by gram molecular weight into 1 by V in liters. But what about in ml? We can convert this equation into ml. Weight by gram molecular weight into V in liter. 1 liter equal to 1000 ml. So ml is equal to liter by 1000. So weight by gram molecular weight into 1 by V by 1000 in ml. Then this equation becomes as weight by gram molecular weight 1000 by V in ml. This is equation for molarity in ml, and this is the equation for molarity in liters. So molarity is the term by which we can quantify we can express the concentration of solution. Concentration means amount of solute present in that solution. So molarity is a unit by which we can express the chemical substances in solutions, and there are several units are there to express the concentration of the solutions, that is molarity, normality, molality, mole fraction, percentage by weight, percentage by volume, percentage by strength, and parts per million. Let us see one by one. Okay, now coming to this equation, so molarity is equal to moles. Molarity is equal to M is equal to moles per liter, V in liters. That is, from this equation we can write mole is equal to cross multiplication, molarity into volume in liter. Next, we can convert this moles into millimoles. Millimoles is equal to molarity into volume in ml. Volume in ml. So, if you multiply the molarity with the volume in ml, that gives millimoles. If you multiply the molarity with the volume in liters, that gives moles. Okay, these two equations are very important in the applications of mole concept in solutions to various applications, right? Okay, and molarity is temperature dependent. Molarity, the term, the unit molarity is temperature dependent, because volume depends on, volume of the solution depends on temperature. So here we are expressing the volume in liters. So volume of the solution depends on temperature. So molarity is temperature dependent. So molarity is temperature dependent. Next, we shall go for normality. Normality. N. Normality. Definition of normality is number of equivalents of solute present in 1 liter of solution. Number of, I repeat, number of equivalents present in 1 liter of solution. That can be written as normality is equal to number of equivalents of solute, equivalents of solute. What is that definition? Number of equivalents of solute present in 1 liter of the solution. So 1 liter of the solution, usually we can write 1 liter of solution. 1 liter of solution. So normality is equal to equivalent of solute by volume of the solution in liters. So equivalent is equal to normality into volume in liters. We can get the milli equivalents of solute, milli equivalents of solute by multiplying the normality into V in ml. V in, again these two equations are very important. Okay, so normality is number of equivalents of solute present in 1 liter of solution. Normally, usually we see the equation for normality is the formula for the normality is, we can get the formula what we usually see in the textbooks, that is normality is equal to equivalent of solute. Equivalent of solute means equivalent weight, equivalent of solute ante weight by weight of solute by its gram equivalent weight by 1 liter by V. So we can write weight of solute by gram equivalent weight of that substance by 1 by V in liters. And we can convert this liters into ml, weight by gram equivalent weight into 1000 by V in ml. This is normality. This is the equation usually we see in the textbooks, but that is basic equation for normality, basic equation to find out the normality of a particular solution. But you should remember these two equations, because in applications these two equations are very helpful in solving the problems. Again, normality is also temperature dependent, because it involves volume of the solution. Volume of the solution depends on temperature, so normality is also temperature dependent. Now we shall go for molality. And one more thing is that normality and molarity, by these two units usually we express the concentrations of solutions. Okay, again I am telling you that normality, molarity, molality, mole fraction, parts, ppms, all these are units to express the concentration of these solutions, right? Next, molality. Molality, it is represented by small m, and the definition for molality is number of moles of solute present in 1 kg of solvent. Number of moles of solute present in 1 kg of solvent. This can be written as molality m is equal to number of moles of solute present in 1 kg of solvent. 1 kg of solvent. Again, number of moles of solute, we can find that number of moles of solute by the equation weight by gram molecular weight into 1 by kg of the solvent. 1 by kg of 1 by V, or sorry, 1 by mass of the solvent, 1 by kg. 1 by kg. Usually we represent this solvent as with A, or some members are represent in some textbooks, or some chemists represent with solvent. Some chemists represent this solvent with A, and some chemists represents that solvent with W. So 1 by weight of solvent in kg. We can convert this equation into grams, weight by gram molecular weight into 1000 by A in grams. This is the definition for, this is the basic equation for molality, and you should remember that molality is temperature independent, because here mass remains unchanged, so molality is independent of temperature. Okay, now we shall go for mole fraction. Mole fraction. Xi. It is denoted by Greek letter xi, right? Mole fraction. It is actually, mole fraction is the ratio of already I told you solution contains two components. We can convert that two components into moles, and mole fraction is a ratio of number of moles of one component to number of moles of solution. That is, solution is equal to solute plus solvent. If you take A as solute and B as solvent, okay, A has its own number of moles and B has its number of moles. Okay, so molality is equal to mole fraction. Mole fraction is the ratio of number of moles of one component to number of moles of solution. That is, number of moles of one component A by number of moles of solution means number of moles of solute plus number of moles of solvent. So this is mole fraction, by which we can also express the concentration of solutions. Okay, so usually molarity and normality are very familiar. Okay, now by that two units we express the concentration of the solutions, right? Now we shall go for percentage. There are three types of percentage, that is percent by weight, percent by weight, percent by strength, 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 percent by volume. By these three percentages also we can express the concentrations of the solutions. Percent by weight, the formula for percent by weight is weight of solute by weight of solution into 100, and percent by strength is volume of solute by volume of solution into 100, and percent by volume is equal to volume of solute, weight of solute by volume of solution into 100. Usually percent by weight is called as a weight by weight percent, percent by strength is called as a volume by volume percent, and percent by volume is called as a weight by volume percent. Weight by volume percent. By these three types of percentages we can express the concentrations of the solutions. For example, 70% by weight solution is there. How much amount of solute is there and how much amount of solvent solution is there? That means 75% by weight of solution means 100 grams of solution has 75 grams of solute, and 75% by strength, that means 100 ml of solution has 75 ml solute. and 75% by volume, that means 100 ml of solution has 75 grams solute. Okay, so in this way also we can express the concentrations of solutions. Now we shall see the parts per million. Parts per million. Parts per million, ppm. ppm is defined as weight of solute present in 1 by millionth part of mass of solution. I repeat, ppm is defined as weight of solute present in millionth part of mass of solution. Okay, so this can be written as weight of solute present in millionth part of weight of solution. Usually weight or mass, those are those two we can use weight and mass in chemistry, but in physics we could not use the term weight and mass as synonyms, because weight is equal to mg and mass is not equal to, there is no impact of gravitational force on mass. Okay, so we can write mass of solute instead of weight. Mass of solute present in millionth part of mass of solution. So mass of solution, if we take mass of solution, in the mass of solution millionth part, millionth means 10 power 6, so ppm is defined as mass of solute present in millionth part of mass of solution. So mass of solution, if you take the mass of solution and its millionth part, and then how much mass of solute present in millionth part of mass of solution is called ppm. Now we can write this equation: mass of solute by mass of solution into 10 power 6. In this way also we can express the concentrations of solutions. Okay, so molarity, normality, molality, mole fraction and parts per million, these are the units by which we can express the concentrations of solutions. And concentrations of solutions and molarity, normality, mole fraction, all these concepts involves the and all in this equations, and molarity, if you take molarity equation, there is a mole concept there. If you take normality, there is equivalence, there is a concept of equivalent. Okay, so of course there is another two units, that is formality and mass fraction. Those are not familiar. Okay, so these are units by which we can express the concentrations of solutions. And one more thing is that you should kept in your mind that molarity and normality are temperature dependent. Wherever is the volume of the solution is considered, there is a temperature effect. So molarity, normality are temperature dependent. Molality, mole fraction and percent by weight are temperature independent. Okay. In the next video, we shall discuss the applications of mole concept and equivalent concept. Okay. Thank you.